Now look at this. If I have y equals to 1 over x, either it comes in this form or it comes in this form. F of x is equals to 1 over x. So it shows y is a function of x, right? Now, before I can differentiate this, I need to make it in a linear form. In the form of what? A raised to power what? N. Is that taken now? So in this case, I will say that my y can also be written as what? 1 times, this one has 1 here, right? When it's coming up, it will be s raised to power what? Minus 1. Because when it changes position from base to give it to attract a negative sign. So now, which is something are saying y is equals to what? 1 times anything will give you that thing, minus 1. Are we good? Now, if I differentiate this, the y all over what? The x. It will be x raised to power what? Minus 1. The minus 1 will come in front of this. Then I'll subtract 1. So this will now give me minus x raised to power minus 2. So if I'm taking this back, you should have in your mind that everything has a 1 close to it. So this will give me 1 all over x squared. Let's put the minus there because there's a 1 there. So when this is going back, it will become, the minus will leave and become just 2. Is that taken now? So this is my dy over what? Dx. Now if you come here also, like I said earlier, it's like saying f of x prime is equals to what? Minus 1 all over what? X squared. So it's the same thing. The y over the s means f of x prime. Are we good? Now similarly, if I am told to do this again, so it will be the square y over what? The x squared. Right? So what it means is I cannot just do it this way, except I want to start going into quotient rule and so on. But to do it on the basic way of differentiating is that I'll make it in linear form. This 2 will go back again. So it will be minus 1 x raised to power what? Minus 2. Are we good? It will go back again. So from here, since I've written the square y over the s square, means I will differentiate. So this minus 2 will come down. So I'll be having minus 2 to come and multiply this minus 1 here. Is that taken? And I'll subtract 1 from it. So this will give me 2 times, minus 2 times will give you 2 x is minus 3. Right? So if I want to rewrite this to be 2 all over what? S cubed. So this is my d square y over my dx squared. That is the d square y over what? The x squared. Or I can easily say f prime prime of x is equals to what? 2 over what? S cubed. Now if I'm told to do it again, I must not use it this way. So another way of writing this guy, that means my d square y over the s squared, I must put it in this form, a s raised to power n. So it will be 2 x minus 3. Because when it's coming, it will become minus. Is that okay now? So if I now do it again, the cube y over what? The s cube, and that will be, we have 2x minus 3. So the minus 3 will come to the front. We have minus 3 times this. I'll subtract 1. And this will give me minus 3 times 2 give you minus 6. X minus 3 minus 1 will give you minus 4. So therefore, my d cube y over the s cube will give me minus 6 over what? X4. Are we good? Or I can say my f prime 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 of x is equals to what? Minus 6 over x4. It can continue that way, right? Let's go one more. Now, if I want to differentiate again, I should always put it in this form, right? So I'll be having my d cube y over the s cube will give me minus 6x minus 4. So always being in a linear form. So if I now want to do it again, the 4 all y over what? The x4 will be minus 6. I write it out. 4. Since I put the 4, this one will come down minus 4 here, minus 6. Then I'll subtract 1 here. Mind you, this one is in the bracket, so you not get it confused. So this will not give me minus 4 minus 6 will give you minus, that is positive 24, right? So we have x minus 5. So I will now say my d4 over the x4 will be equals to what? 24 over what? x5, or my FIV is equals to what? 24 over what of x is equal to 24 over what? x5. Please understand that concept. Thank you.